So 51 through 54, we're still using the standard normal distribution formula, but we're solving for something different. In all of the previous examples, we solved for z, and these problems we're solving for something different. Let's see. So x is a normally distributed random variable with a mean of 8. Mean is 8. Standard deviation is 2. Find the value of x for which 70.54 of the area under the distribution curves lies to the right. So this area here is 0.7054, 70.54%. I want to know this x value here, this x value here, this value. So if I'm looking at the table, again, the table gives me the values to the right. So this is if I subtract from 1, 0.2946. So let me look at the table for this value and see where that gets us, right? So let's look at the table for 0.2946. 0.2946, 0.29. Well, we got it, 0.2946 exactly. So that's negative 0.54. Negative 0.54. So this z value, z equals negative 0.54. That's not what we want. We want the value of x. So we have the z value, but we want the x value. Let's take a look at our formula. We have the z value, negative 0.54. We don't know the x value, but we know the mean, and we know the standard deviation. So we're just solving for x. We did it in some problems before. Let's cross multiply. X minus 8 equals 2 times negative 0.54. X minus 8 equals negative 1.08. Add 8. So x equals 6.92. That's the x value. So this z value is negative 0.54. X equals 6.92. And that's the x value there. All these problems have the same kind of slant to it. 52. X is a normally distributed random variable. Mean is 11. Standard deviation is 4. Find the x value. Find the x value such that the probability that large x is less than x. That's what the table gives us. Less than. This area here is 0.86. Less than 0.86. Let's just look for it in our table. Let's go over 0.86. That's probably on the right side here. I mean, positive z values. 0.86. I think that's it right there. 1.08. Right? 1.08. That's 0.86. 1.08. 1.08. So this z value here is 1.08. This thing isn't drawn to scale, but it's close enough. The z value is 1.08, but we want x. Let's do it again. 1.08 equals the x value minus the mean divided by 4. I want to solve this thing for x. X minus 11 equals 4 times 1.08. X minus 11 equals 4.32. Add 11. Add 11. X equals 15.32. And that is your x value. So z equals 1.08, x equals 15.32 in normal numbers versus in normal numbers for this situation versus the standard normal values. Okay, let's check out 53. Same kind of feel, right? Same kind of feel. X is a normally distributed random variable, standard deviation of 4. They want us to find the mean when 64.8 of the area lies to the left of 8 point. So this is 0.648. And they give us here, they give us the x value. They give us the x value, x equals 8.52. They give us the x value, x is 8.52. And we need to find, let's find the z value here. And once we find the z value, then we can convert, we can figure out how to solve for the mean, because we'll have the z value, we'll have the x value, we'll have 4, and then we can kind of go from there. We'll have the standard deviation, and then we can go from there. Okay, so let's go look at the table for 0.648 to find that z value. 0.648. 0.64. Oh, there we go. 0.648. That's 0.38, right? 0.38, 0.38, 0.38, 0.38. So this z value is 0.38. So if I think about this formula, z equals x minus the mean divided by the standard deviation, I've got 3 parts to solve for the fourth. I know z. I know x. I don't know the mean. That's what I want. Divided by 4. Yeah. So I'm going to solve this the same way. Cross multiply. 8.52 minus the mean equals 4 times 0.38. So 8.52 minus the mean equals 4 times 0.38, which is 1.52. Subtract 8.52. All right. So negative mean equals negative 7. So that means my mean equals 7. That's where I am. The mean is 7. And ta-da, we're good to go. Let's look at the last one. 54. Let's see if we can do something good here. Okay, so 54. X is a normally distributed random variable. Standard deviation of 2. Find the mean again. If 12.71 of the area, the shaded region here, 0.1271, lies to the right of x equals 7.28. They're giving us the info. We just have to interpret it and figure out what we do from there. All right. So table always gives us to the left. Let's just work with that. So that's 0.9729. No, 0.8729, sorry. 0.8729. Yep. Okay, so let's look at the table for 0.8729. Find the z value, and let's solve for this mean. 0.8729. Not going to be here, it's going to be here. Oh, I see it right away. Look at that. My eyes are getting better. 0.8729, 1.14. 0.8729, 1.14. That's that z value. That's that z value. I forgot it. 1.14, right? Is that what we said? 1.14. Yep. I just want to make sure, because I don't want to make a mistake and then you start yelling and screaming at the computer or at the phone or whatever. So z is 1.14. Here we go. Using this formula that's on your trusty formula sheet. So, whoops. I know z now. Come on. So 1.14 equals 7.28. That's my x value. Minus the mean, which we're trying to solve for, divided by 2. Let's cross multiply. 7.28 minus the mean times 1 equals 2 times 1.14. 7.28 minus the mean equals 2.28. Subtract 7.28. Subtract 7.28. We're solving for the mean. Negative mean equals -5. So that means the mean has to be 5. The mean is 5.